Okay, so this is section 6.1, and this covers multiplying and dividing rational expressions. Okay, so let's start off talking about what a rational expression is. A rational expression or rational function you've talked about in college algebra at this point. It is a fraction that has x's on tops and bottoms, excuse me. So a rational function would be like y equals, I don't know, x plus 2 over 2x minus 5. You did lots of things with those in college algebra on your exam number 2. What's one thing that's special about rational functions? Yeah, you set it equal to 0. Specifically, you set the bottom equal to 0. And what does that give you when you set the bottom equal to 0? Do you remember what it's called? Yeah, a vertical asymptote. Rational functions have vertical asymptotes, and the reason why they have vertical asymptotes is because our domain is restricted. There's a specific number that will not make this work because it gives you a 0 on bottom. So that's a vertical asymptote on your graph. Okay, so basically the domain is restricted for these. We have spent time finding where the domain is restricted. How do you find where the domain is restricted, or how do you find the vertical asymptote? Take the bottom and set it equal to 0, right? So to find the domain, you do the 2x minus 5 equals 0. Set the bottom equal to 0 and solve. If I add 5 to both sides, I get 2x equals 5. Divide by 2. And I get x equals 5 over 2, or you can think about that as 2.5. So that number that you found is the one number you're not allowed to have for this problem. That's where your vertical asymptote is. So the domain for this function would be negative infinity to that number, 5 halves, union 5 halves to infinity. Okay, remember going over that? Today, we're just going to talk about rational expressions. So the difference between an expression and an equation is an equal sign. This one has an equal sign. Expressions don't have an equal sign. So it's just this part of it, the x plus 2 over 2x minus 5. Okay. We're going to talk about how we multiply and divide, or how we simplify it, how we multiply it, and then how we divide it. So we're going to start off just with simplifying first. Okay, all that a rational expression is just a fraction that has x's in it. So we simplify rational expressions the same way we simplify regular fractions. So let's kind of review how we simplify a regular fraction. If I had the problem 15 over 65, just plain old fraction. Can I simplify that fraction? Yeah, you can reduce it. Reduce and simplify means the same thing. How do you reduce it? Divide by 5 on top and on bottom. Uh-oh, divide by 5. I don't know why I did that. 15 divided by 5 is 3. 65 divided by 5 is 13. So you would get 3 over 13. Okay, so think about if this problem had x's in it, like if it was like x squared plus 2x plus 7 on top, would you want to find the common factor and divide by that common factor? Think about how you divide. That's like synthetic division or long division. Is that fun to do? No. So because of that, because we don't really like to divide with x's, instead, we're going to think about this problem differently. A different way you can think about this problem is breaking it up into the factors. What two things multiply to give me 15? 3 and 5. So I can rewrite 15 as 3 times 5. Two things that multiply to give me 65 is 13 times 5. I haven't changed the problem at all. I've just rewritten it. And now, do I have a factor on top and bottom that are the same? Yeah, 5. What is 5 divided by 5? 1. So essentially, I can just like divide these out. You could also think about like canceling them out if you wanted to, because it's the same idea. And you're left with 3 over 13. It's the same answer, just kind of a different way to think about it. So instead of dividing, what we're going to do for these problems, the first thing we're going to do is factor each problem. And then after we factor, we are going to divide out, that's the same thing as cancel, common factors. And just a reminder, your common factors, one has to be on top and one has to be on bottom to cancel them out. You can't cancel out two things on top or two things on bottom. Okay, so let's get going on these. First example, if I had the problem, x plus 2 over x squared minus 4. Okay, the first thing we do is factor, top and bottom. The top, x plus 2, does it factor? No, there's nothing to do there. It's just x plus 2. If you wanted to go ahead and put parentheses around it to remind yourself that like it's already factored, there's nothing to do there, that might be helpful. On bottom, x squared minus 4, does that factor? Yeah, what does it factor into? It's the difference of two squares, two sets of parentheses, one's a plus, the other's a minus, take the square root. So x goes at the beginning, 2 goes at the end. So now, do I have common factors? Yeah, if you look on top, I have an x plus 2. On bottom, you have an x plus 2. So these two are your common factors. Usually I do this on white paper, and this highlighter is really helpful, but you can't really see it very well here. So those are my common factors that I can cancel out. What's left on top now? On top? 0, nothing's left on top, so I put a 1 there, right? Because it's like I don't have a top there, so I have to put a 1 on top. And on bottom is going to be x minus 2. And that's your answer. So it's the same idea as just reducing a fraction. It's just I don't want to have to divide, so I just factor it to write it as the factors. Okay, what about if I had this problem? 4x squared over 10x to the third minus 2x squared. Okay, look at the top. Can you factor the top? Yes, no. I mean, like, there's no like way to factor this. I could, if you wanted to, rewrite 4 as 2 times 2. If you wanted to. You could write it as x squared. You could write it as x times x. Same idea, right? Look at the bottom, though. 10x to the third minus 2x squared. I need to factor that. That is greatest common factor. What's the greatest common factor for 10x to the third minus 2x squared? 2x squared is the biggest thing you can take out of both. What's left over from 10x to the third when I divide by 2x squared? 5x minus, I have 2x squared. I take out 2x squared. What's left over? A 1. So now what's the same on bottom and on top? A 2 and a x squared. So that's what can cancel out is a 2 and an x squared. What's left on top? 2. What's left on bottom? 5x minus 1. And that's your answer. Questions about that? Okay, look at this problem. If we had 9x squared plus 13x plus 4 over 8x squared plus x minus 7. How am I going to factor the top? AC method, right? Is this a shortcut problem? No. So I'm going to come over to the side or down on the bottom. A is 9, B is 13, C is 4. A times C is 9 times 4, which is 36. What two things multiply to get 36 and add to get 13? 9 times 4, right? 9 plus 4 is 13. So I rewrite my problem as 9x squared plus 9x plus 4x plus 4. I rewrote 13x as 9x plus 4x. And then what do I do from here? Factor by grouping, right? Put the first two together, put the second two together. The first two, 9x squared plus 9x, what do they have in common? 9x. When I take out a 9x, left over is x plus 1. 4x plus 4, what do they have in common? 4. When I take out a 4, left over is x plus 1. Now they have the x plus 1 in common, so I can pull out x plus 1. Left over is 9x plus 4. So the top factors into x plus 1 times 9x plus 4. The bottom, 8x squared plus x minus 7. How do you factor that? It's an AC method also. It's not a shortcut problem either. Usually I just kind of give the answer to this. I'm like, you know how to factor it. I'm going to give you the answer. But I feel like it's been a long time since we've done these problems. So it's good practice because this is on your final exam. Okay, so A value is 8. B value is 1. C value is -7. A times C, 8 times -7 is -56. We're trying to get two things that multiply to give me 56 are 8 times 7. To make it +1, which one needs to be negative? Yeah, the 7 has to be negative, the 8 has to be positive. So let me go in and rewrite my problem. 8x squared plus 8x minus 7x minus 7. And then we factor by grouping again. So 8x squared plus 8x, what's the greatest common factor there? 8x. So I'm going to pull out an 8x. Left over is x plus 1. -7x minus 7. I can pull out a -7, and left over is x plus 1. Okay, so then I pull out the x plus 1. Left over is 8x minus 7. So that's my denominator. X plus 1 times 8x minus 7. So now, common factors. What common factors do you have? X plus 1. That's what I can cancel out. And left over is, I kind of am out of room here. I'm going to come do it way down here. 9x plus 4 on top over 8x minus 7 on bottom. Okay, so that was a very long problem. Usually you don't have quite that much factoring in each problem. It was good practice though. I feel like it was a good use for our time right now. But usually you're not going to have quite as much factoring, quite as much long factoring in each problem. Usually you have some more short ones in each problem. Does that make sense how to do these though? Simplifying? Okay, there are a few little tricks in here. So let me show you the tricky things. If I had the problem, I guess this would be number 4. If I had x plus 2 over 2 plus x, are those common factors? Can I cancel those out? Are they the exact same thing? It's kind of a tricky one. So like, think about it. If I take a number and add 2 to it, is that the exact same thing as taking 2 and adding that same number to it? Is 2 plus 6 the same as 6 plus 2? Yeah. Is negative 5 plus 2 the same as 2 plus negative 5? Addition is commutative. That's the word there. You can move it around. So you could, if you wanted to, rewrite either the top or the bottom. I'm going to rewrite the bottom. I'm going to put the x part first. Is the x positive or negative? It's positive. Then I'm going to put the 2. Is the 2 positive or negative? Positive. So it's going to be x plus 2 and x plus 2. Those are common factors and they can divide out, right? If I divide out everything on top and on bottom, what's left over? 1, because something divided by itself is 1. Okay, so if everything's positive, if it's just an addition problem and they're written backwards, you can rewrite them the same way and then cancel them out. What about subtraction? What about if it was x minus 2 over 2 minus x? Is that the same thing? No, think about a number. If I plug in 4, is 4 minus 2 the same thing as 2 minus 4? No. Is 10 minus 2 the same thing as 2 minus 10? No, you get the same number, but one of them is negative, one of them is positive, right? So the idea here is I can still kind of cancel these out. I'm going to rewrite the bottom. I'm going to keep the top as x minus 2. On bottom, I want to put the x part first. Is x positive or negative? It says minus x, so it's a negative x. So you put negative x first. Is 2 positive or negative? Positive, so you put plus 2. So now they almost look the same. What's the difference here? Just the signs, right? This x is positive, this is negative, this is a negative 2, this is positive 2. On bottom or on top, it doesn't really matter which one you do it to. If I factor out a negative 1 as a GCF, negative x divided by negative 1 is positive x. Positive 2 divided by negative 1 is negative 2. Now do they match? Yeah, they match now. So you can cancel out the x minus 2, and what's left over here? Negative 1. That should kind of make sense a little bit, because if you plugged in number here's negative 4 minus 2 was positive 2. 2 minus negative 4 is positive, I'm sorry, negative 2, and 2 divided by negative 2 is negative 1. Okay, so if everything's the same except for the signs, if the signs are what's the issue from canceling it out, you can factor out a negative 1 to make them match. Okay, I'm probably not going to do this too much on your tests and your final exam because I feel like it's a little bit tricky and it's kind of not fair. My goal is not to trick you. I just want to see if you know how to do it. So I'm probably not going to do that on your test, but math, your homework is going to do this on some problems. Okay, so if it looks really similar and just the signs are different, if you factor out a negative 1, that fixes your problem. Okay, so let's do one more with that in there real quick, and then we'll move on. If I had x squared minus 9 over x squared minus 2x minus 3. On top, x squared minus 9, how does that factor? The difference of 2 squares, x plus 3, x minus 3. On bottom, x squared minus 2x minus 3. We use AC method for that. Is it a shortcut problem? Yes. So I'm just figuring out what two things multiply to get negative 3 and add to get negative 2. -3 and +1 are what add to get -2. So this is x minus 3, x plus 1. So now what's exactly the same on top and on bottom? The x minus 3's. That's what cancels out. And so we're left with x plus 3 over x plus 1. Okay. On these, some people start to get what I like to call cancel happy, where they just start canceling crap out. Like at this point, you can't cancel the x's out, because if you think about it, if I was going to plug in a number for x, 4 plus 3 over 4 plus 1. 4 plus 3 is 7. 4 plus 1 is 5. Can 7 over 5 reduce? No, you can't cancel out the 4s and 7. You see what I'm saying? So if it has a plus sign or a minus sign, think about it as having parentheses around it. And you can only cancel out if everything in the parentheses is exactly the same. Okay, so don't just start canceling stuff out because it looks the same. Like it has to have parentheses around it if it has a plus or a minus sign. They're connected together. Okay, so that's simplifying. That's essentially the main idea for today. Multiplying and dividing takes that and just adds a little bit onto it. So let's do multiplying now. And for multiplying, I'm going to start off with a regular fraction problem and kind of show you how we're going to do it when we put x's in it. So if I had the fraction 2/5 and I wanted to multiply it by 15 over 8. One way you can multiply fractions, multiply across the top, multiply across the bottom, right? If I multiplied across the top here, 2 times 15 is 30. 5 times 8 is 40. 30 over 40 reduces to, I could divide them both by 10, right? And I would get 3/4. That is one way to do the problem. Think about if this had x's in it though. If say this on top right here was like x squared plus 5, and this one right here was like x squared plus 2x plus 10, do you want to have to multiply and FOIL that out just to reduce it later on? No, it would take a while to do that. I mean, you could do it that way, but it's so much extra work. So instead of doing that multiplication problem that way, the way we're going to do it is I'm still going to keep it as 2/5 times 15 over 8. 15 I can write as 5 times 3. And 8 I can write as 2 times 4. And this is a multiplication problem. So it's essentially like I could connect them, right? And just like multiply the stuff on top and multiply the stuff on bottom. So now what factors do I have that are exactly the same on top and exactly the same on bottom? A 2 and a 5. If I cancel out those 2's and 5's, what am I left with? 3/4. Did I have to simplify? No. So essentially, and this is how I actually do multiplication problems, I simplify before I multiply it so that there's less to multiply. You could multiply first and simplify, but sometimes if these numbers are really big, that's a lot harder to do it that way. Okay, so that's what we're going to do for multiplication. The first step you're going to do for every problem is factor. The second step is divide out common factors, anything on top with anything on bottom. And it doesn't matter which side of the multiplication sign it's on. So it's essentially the same idea as a simplifying problem. It's just a little bit bigger because I have more pieces to factor and cancel out with. Okay, so let's do some of those problems. If I had the problem 3x plus 1 divided by 2x times 2x minus 4 over 3x squared minus 2x minus 1. Okay, look at the top of the first one. 3x plus 1, can that factor? No, so I'm just going to rewrite it as 3x plus 1. Look at the bottom of the first one, 2x, can that factor? No. One thing about 2x though, are there any plus or minus signs there? No, so that's actually two pieces. That's like 2 times x, just FYI. Like I could cancel out just the 2 or cancel out just the x. I couldn't do that on top with the 3x and the 1. I can't separate those because that is one piece right there. Does that make sense? The difference between multiplication and addition and subtraction. Look at the top of the second one, 2x minus 4. Can I factor that at all? You can take out a 2, right? As a greatest common factor of a 2. When I take out a 2, what's left over? X minus 2. And on bottom, 3x squared minus 2x minus 1. How do I factor that? AC method. So I'm going to come over here on the side. A is 3, B is -2, C is -1. A times C is 3 times -1 is -3. What two things multiply to get -3, add to get -2? 1 and 3, and the 3 needs to be negative. Is this a shortcut problem? No. So I got to rewrite it. 3x squared minus 3x plus 1x minus 1. Factor by grouping. (3x squared minus 3x). What's the greatest common factor there? 3x. Left over is x minus 1. Positive 1x and -1. The greatest common factor there is just 1. So I have an x minus 1 in common now. When I pull that out, left over is 3x plus 1. So I can write that on the bottom of my fraction. X minus 1 times 3x plus 1. Okay, so everything's factored now. What can I cancel out here? 3x plus 1 on top of the first and bottom of the last. And that 2, the 2 on top of the second one and the 2 on bottom of the first one, you can cancel out. Everything else is different. So my answer is you just put it all together. What's left on top? X minus 2. What's left on bottom? X and x minus 1. You could multiply it out. I would not spend the time doing it. I'd just leave it like that. That's your answer. Questions about that? Yep. No, I think it wants you to leave it like that. I'm like 90% sure on that answer. I know. Let's do another one. What if I had, we're not gonna do that one. What if I had 2x squared minus 2 over 10x plus 30 times 12x plus 36 over 3x minus 3. Okay, on the top of the first one, 2x squared minus 2. I can't do the difference of 2 squares there because it's 2, but there's a greatest common factor, right? So take out the greatest common factor. When I take out the greatest common factor, I get 2 times x squared minus 1. Can I factor that x squared minus 1 now? Isn't that the difference of 2 squares? Like you can do the difference of 2 squares, you just had to take out the 2 first. So this is actually 2 times 2 sets of parentheses. One's a plus sign, one's a minus sign. Take the square root. So we have x and 1 and 1. Everybody tracking with that? On bottom, 10x plus 30. What's the greatest common factor you can take out? A 10. Left over is x plus 3. On top of the second one, 12x plus 36. What can you take out? A 12. Left over is x plus 3. On bottom, 3x minus 3. Take out a 3. Left over is x minus 1. Now for the fun part, what can you cancel out or divide out? Okay, so on top of the first, I have x minus 1. On bottom of the second, I have an x minus 1. On top of the second one, I have an x plus 3. On bottom of the first one, I have an x plus 3. Okay, I can't do anything with this x plus 1. That's going to be my answer. But look at all my numbers. I have a 2, a 10, a 12, and a 3. Do you think I can divide out some of those numbers? Couldn't you rewrite 12 as 4 times 3 so that you can divide out your 3's? Right? So then I can divide out my 3's. So now I have a 4 left, a 2 left, and a 10 left. I can't cancel out the, like I could rewrite this 4 as 2 times 2 and cancel out the 2's. Why can I not do that? They're both on top. You have to do a top with a bottom. Can I rewrite 10 as 2 times 5 and do a top and a bottom? Yeah. So I'm going to rewrite 10 as 2 times 5. And I'm going to cancel out a 2 on top with a 2 on bottom. I'm going to do this 2 right here at the beginning on the top. But technically, could I break down that 4 times 3, 4 into 2 times 2 and pick that 2 in this 2? It doesn't matter which 2 you do. Just only pick one of them. You can't do both of them. Okay. 1 for on top for 1 on bottom. So my answer is, what's left over on top? 4 and x plus 1. So 4 is on the outside times x plus 1. What's left on bottom? Just a 5. And that's your answer. Another way you could have done it, you could have multiplied 2 times 12 to get 24. On bottom, it was 10 times 3 to get 30. And 24 over 30 will reduce to 4 over 5. I feel like that's just a little bit harder than doing it this way. Questions about that? Okay, we're going to stop there. When we come back on Friday, we will do some more multiplication and we will finish up with division and be finished with all the new material for the whole semester. I do have a review for you. So let me stop recording this.